All right, welcome to the Explainer. Today, we're going to dive into something that could be a total game changer for how we use AI. It's called the Model Context Protocol, or MCP for short. And we're going to start with a question you've probably asked yourself more than once. Why does it feel like your super powerful, cutting-edge AI assistant is completely, well, blind? You know what I'm talking about, right? You've got your whole project open, maybe an error log staring you in the face, but the AI, it has no clue. It's just sitting there in the dark.
It can't see what's on your screen. It can't see the code you're working on or that brand new error message that just popped up. And that disconnect, that gap between the AI's brain and your actual workspace, that's what we call the AI context gap. And it's the #1 problem we need to solve.
So what's the fix? Well, that's where the Model Context Protocol comes in. At its heart, MCP is just a standard, a common language that lets AI applications get the context they so desperately need directly from all the other programs you're using. And here's the best way to wrap your head around it. Think of MCP as the USB for AI. Seriously, just like a USB port lets you plug any device into your computer so they can talk to each other, MCP creates a standard way for any app to plug its context right into your AI. It's a simple idea, but it is incredibly powerful. All right, so here's how we're going to break this down. First, we're going to dig a little deeper into that AI context gap. We really need to understand the problem before we can appreciate the solution. Then, we'll look at how MCP is designed to be that universal bridge, that standard that everyone can build on. And after that, we'll see how that bridge actually works. We'll meet the key players in the system and see how they all communicate with each other. So in any MCP setup, you've basically got 3 main players on the field. First, there's the MCP host. That's the AI app itself. Think your code editor or a desktop AI assistant. Then you've got your MCP servers. These are the programs that hold all the juicy context, like Sentry with your error data, or just a little server that can read your local files. And finally, you have the MCP client, which acts as the dedicated middleman between the host and one single server.
And the way this is set up is actually pretty brilliant. The main AI app, the host, doesn't try to have one big, messy conversation with every server at once. No way. Instead, it spins up a separate, dedicated client for each and every server it wants to talk to. So you get one client for Sentry, another for the file system. You get the idea. It keeps everything in these clean, one-to-one channels, which is just a much more stable and scalable way to do things.
The protocol itself is cleverly split into 2 distinct layers. First, you have the data layer. You can think of this as the what. It defines the actual messages, the vocabulary, like here are my tools or here's a notification. And then you have the transport layer. This is the how. It defines the pipeline, the actual connection itself. It could be a super fast local connection right on your machine, or it could be an HTTP connection to a server halfway across the world. Okay, so we know the data layer is about what gets said, but what's on the menu? What can these programs actually talk about? Let's dive into the actual language of context. An MCP server can offer up 3 main types of things, or primitives. First up, tools. These are actual functions the AI can ask the server to run, like, hey, go call this API, or go run this database query. Second, it can offer resources. This is just data the AI can read, like the contents of a file. And finally, it can offer up prompts, which are basically helpful templates to guide the AI. But here's where it gets really interesting. It's not a one-way street. The server can actually ask the AI host for things too. For example, it might need to ask the human user for some input, or it might ask the host's AI model to help it complete a thought. This back and forth, this 2-way communication, is what makes the whole system so powerful and interactive. Okay, enough theory. Let's make this real. How about we walk through a quick, simple conversation to see how all these pieces actually fit together? So, everything kicks off with a handshake. The client sends an initialized message to the server. But they're not just saying, hi. This is a negotiation. They're agreeing on what version of the protocol they're speaking, and most importantly, they're telling each other what they can do. The server might say, hey, I've got tools, and the client says, great, I know how to use those.
Now that they're on the same page, the client can ask a very simple question. So what have you got for me? It sends a tools/list request. In response, the server sends back a complete menu of all the tools it has, with descriptions of what they do and what information they need to run.
Okay, now we get to the good part, the action. The client looks at the menu of tools and says, I want that one. It sends a tools/call request specifying exactly which tool to run and giving it all the arguments it needs. In this case, asking for the weather in San Francisco.
And boom, there's the magic. The server goes off, does its thing, and sends back a nice, clean response with the information. Just like that, the AI host has real-time useful context. It's not working in the dark anymore. But hold on. What happens if the server's tools change? Maybe a new one is added. Does the client have to keep asking, anything new, over and over again? Nope. The server can be proactive. It can send a little notification that just says, hey, by the way, my tool list has changed. You should check it out again. And that notification system is really the secret sauce. It makes the whole protocol incredibly dynamic and efficient. The AI doesn't waste energy constantly checking for updates. It can just sit back and wait to be told when something important has changed, ensuring it always has the freshest information. So, let's pull back and look at the big picture here. What does this all add up to? If this works, it leads to a future that is truly, deeply context-aware. And why does that matter so much? Well, first, by standardizing everything, it lets developers go wild building amazing specialized context providers, knowing that any AI can plug into them. This creates a whole ecosystem of tools that can all talk to each other. We move away from today's world of siloed AIs and toward a future of truly integrated intelligence. So I'll just leave you with this one question to think about. What will you build? What will we all build when every single application can securely and seamlessly share what it's doing with your AI? The possibilities are pretty mind-blowing. Thanks for joining me on The Explainer.